How do you represent numbers that are really, really small or numbers that are really, really large? Well, you use something called scientific notation. Okay? And in this video, I'll be going over the basics of scientific notation and how to change between standard and scientific notation. So make sure you pay attention and let's go at it. So there are a few rules for scientific notation. It's always going to be in the form of a times 10 to the n, where a can be any number between 1 and 10. Now, why is that? Because one of the rules of scientific notation is there can be a two-digit number here because we want to add as many possible orders of magnitude for 10 as we can. So if you add something like 60 times 10 to the 22, well, that's a bit inefficient. You could just remove this 0 and you could say 6 times 10 to the 23, right? So the rule for scientific notation is a always has to have one digit in ones place, okay? Now I say that because it can have more than one digit, but that has to be after a decimal. So it could be 6.022 times 10 to the 23. This is still fine because this doesn't have more than two digits after the decimal, right? This still falls under the constraint of a has to be between 1 and between 10. Okay? If it goes above 10, you can see how, it becomes like 100 and you can just change the decimal points or add more orders of magnitude to the 10 instead of using different numbers, right? We want to maximize the orders of magnitude for the 10. Now, why can it not go below 1? Because then, similarly, you'll have something that looks like this, 0.74 times 10 to the 23. You can write that as 7.4 times 10 to the 22, right? It's just convention to keep it between 1 and 10. You can have something like 1 itself, right? So this is lesser than equal to, but you can't have something like greater than 10 or lesser than 1. Okay? Right, that's it then. The rules of scientific notation, that's how far it goes. Now, n has to be an integer, and a could be a negative value. That's why we have the absolute value of a is between 1 and 10, okay? We just want to know how many digits it has, basically. We don't really care about the sign because it could be a large negative number, right? Like negative 7.4 times 10 to the 56. It could be a large negative number as well. It doesn't need to be positive. But we take the absolute value of a, so we take 7.4, and we see whether that's greater than 1 and lesser than 10. So those are the rules of scientific notation. Now I'm going to show you how to convert between scientific notation. Okay? So one more time, going over the rules before we go into conversion. Why is this one wrong? 65 times 10 to the 22. Try and pause the video and figure it out. Okay. 65 times 10 to the 22. 65 is, look at the constraint for our a value, right? Between 1 and 10. 65 isn't between 1 and 10. The absolute value of 65 is larger than this. So how would I fix it? I would make it in a 6.5 times 10 to the 23. Now, I'll show you how to actually go about the conversion, so don't worry if you didn't understand why the 10 went up and why this one went down. I'm just showing you that this would not fit the rules. If you're ever asked to identify scientific notation, know that this one's not it. Now, what about this one? 0.6 times 10 to the 24. Like the previous one, the absolute value doesn't fit the range, right? Is it lesser than 1? Is it greater than 1? No. So this wouldn't be scientific notation. It's below 1. Okay? It wastes a significant slot, the slot after the decimal. So you would have to go 6 times 10 to the 23. All right. Now let me go between conversions, okay? But before that, try and solve these problems. I'll obviously push out more problems on odds like I do always. But right now, just try and solve these more basic problems. All right, I'm assuming you gave it a try. 3.6 times 10 to the 4. Why is this scientific notation or why is it not? Well, this is, right? Because if you do absolute value of 3.6, that is greater than or equal to 1, and that is lower than 10. So this is fine. This one, we know that the same rule doesn't hold, right? This is wrong. Because this absolute value of 58 needs to be greater than 1, but lesser than 10. This isn't lesser than 10. It's wasting a digit. So I would probably do 5.8 times 10 to the 7. Now let me go over how we convert them, okay? But I'm going to go over that in a few more seconds. Just look at these and just, for right now, just identify with it as scientific notation. This one, it isn't because 0.47 is not greater than 1. Here, 9.1 is lesser than 10, and it is greater than equal to 1. So I would keep it. Now let's go over how to convert between standard and scientific notation. Okay? Assume you're giving something like this. 0.0000456. How would you convert this to scientific notation? First, I locate the first non-zero digit, okay? So 1, 2, 3, 4, 5. This one, 4, okay? And how many steps is that? That's 5 steps to the right of the decimal point. I place the decimal immediately after it. So what do? I take the decimal all the way over here, 4.56, because I only want to have one digit, right, before the decimal. That's why the constraint is 1 greater than or equal to 1 and lesser than 10. And then the decimal, after the decimal, I can have any number of digits. Okay? So now what do? I count the places that it moved. So since it moved 1, 2, 3, 4, 5 places, right? The decimal first it went through all the zeros, but then it also went one more time after the 4, right? So if I was to draw out or trace out the decimal's path, it went like this: 1 skip, 2 skip, 3 skip. So 1 skip, 2 skip, 3 skip, 4 skip, and then 5 skip, because it went after the 4. So then I would do times 10 to the negative 5. Now, do you know why it's negative 5 and not positive 5? Because the decimal moved to the right. And just think about it like this way. If the number is really small, it's going to be a negative, 10 to the negative exponent. Why is that? Because if you think about it, right? Let's just say 2 times 10 to the negative 2. If you know your exponent rules, 10 to the negative 2 is 1 over 100. What is 2 times 1 over 100? That's just 0.02. So you see, when you multiply by 10 to the negative something, you get a smaller number. When you multiply by 10 to the positive something, you get a larger number. That's why the exponent will be negative in this case, because this is a small number. You want to keep that smallness. You don't want to make it large, right? Now let's try a larger number, because that one was smaller, okay? First, try this out on your own. Try to reason through why 7.81 times 10 to the 6 would be equal to 7.81 million. Okay. Now, first, if I want to convert between scientific to standard form, I look at this number, okay? And then I look at how many zeros this 10 has. How many zeros is that? Well, 10 to the 6th would have 6 zeros, right? 10 squared would have 2 zeros because it's 100. 10 cubed would have 3 zeros because it's 1000. So similarly, 10 to the 6th would have 6 zeros. So how would I do 7.81 times 10 to the 6th? Well, first, the zeros here, or which would look like this. You remember how if you had 2.8 or some number that decimal and you multiply that by 10, then this number comes out here, right? So then it becomes 28. That's just what 10 does. It moves the decimal this way. When you multiply it by 10, it moves it to the right. So first we move these two decimals, right? Becomes 781. And how many decimals do we move there? That's 2. So 2 of my zeros are gone. I can only add 4 zeros now. So it becomes this, 7.81 million. Okay. Now, how would I convert from 7.81 million to scientific notation? So I look at this. Okay. And then what do? Like I said, but before, for this one, 4.56 times 10 to the negative 5, I looked at the first digit after the zeros, right? Or I was given the digit like this, and I looked at the first actual digit after the zeros. Not the 0, but the non-zero digit. But here, I look at the first, similarly, I look at the first non-zero digit. But here, I'm going to start at the right. Okay? Here also, I started at the right, and then I went like this. But here, I have places here, right? So I start at the right. I see 7. I'm just going to keep that 7. And then what numbers that are not 0 are here? 0.81. And then what do? I count how many places are after 7. 1, 2, 3, 4, 5, 6. Okay? So it becomes 7.81 times 10 to the 6. For these cases, you would just count the number of digits after the first number. For the smaller numbers, you'd count how many digits did it take you to get to that 0. So over here, you'd count like 1 skip, 2 skip, 3 skip, because it needs to come after the 4, right? Becomes 4.56 times 10 to the negative 3. I hope that made sense. Now, let's try converting these, okay, in both directions. First, let's try this one. 0.0073. So like I said, I count how many digits. I start at the right, and I count till the first non-zero decimal digit. So I look here, I go 1, 2, 3, 4, 7 is over here, right? So I write down 7, and then I write down the digit after that. I know my decimal is going to go over here, so it's going to be 0.3. Now, how many spaces did my decimal move? Moved 1 space, right? 2 space, 3 space, and 4 spaces. So it would be times 10 to the negative 4. Okay? Pretty straightforward, pretty neat. Now, when I look at the larger numbers, what do? I first count the first number, right, from the right. What's the first non-zero number? 6. So I keep 6. And then what do? I do point the non-zero digits, right? Or 5 and 4. And then I count all the places after this, because 5 and 4 are in the decimal, right? 1, 2, 3, 4, 5, 6. Becomes times 10 to the 6. Because there's 6 places after 6, right? 4, 5, 6. All right. Now, what about this one? How would you write this? So convert it from scientific to standard form. So take a minute or two. And now I'm going to go over it. Since this is a negative exponent, I know that the decimal is going to go this way, right? It's going to become a smaller number. But how many times is it going to go that way? Well, if I move it 1 time, that's times 10 to the negative 1, right? So it becomes 0.29 times 10 to the negative 5. Because I moved it once, so then one of these multiplications is gone. Now I only need to multiply it times 10 to the negative 5. How do I do that? Well, when you multiply by positive 10 to the 5, you add 5 zeros, right? But over here, what are you going to do? You're going to add 5 zeros, but after the decimal point. It's going to become 0.0000 0.0029. Okay? So yeah, the 2 shifted basically 6 places, right? And the decimal point shifted 6 places. 1, 2, 3, 4, 5, 6. That's why 10 to the negative 6. You could just count it that way, right? The decimal point keeps moving like this. And then whenever it moves into a place that's not taken, it's a 0, basically. How would I convert this one? Well, this one's a bit more easier than this one, right? This is just regular standard notation. So I know that whenever I multiply by 10 to the something, I add that many zeros. 8.4 times 10 to the 7, I add 7 places. First, the 4 gets carried over because it's one of the places already. It becomes times 10 to the 6. Then I add 6 zeros. So it becomes, I believe, 84 million. All right? Now that's it. If you need more help, then you can obviously book a session on artslearning.com or watch some of my other videos to help it make sense. But for now, that's it. Okay? I'll be seeing you guys in the next video.